Hello everyone and welcome to this session. So let me introduce myself. So I am Ms. Sri Pooja of IT Department of SNSCT. So today under the course of Object-Oriented Programming, we'll explore an essential concept such as exception types in Java. So let's understand how artificial intelligence and smart programming practices make Java error handling more intelligent, efficient, and robust. So in Java, every exception is part of a well-organized hierarchy. At the very top, we have throwable, the root class for all exception types. It splits into two major categories like error and exception. Errors usually represent serious system level problems like running out of memory or stack overflow issues that cannot be recovered from. On the other hand, exceptions represent conditions that a program might want to handle or recover from. So the exceptions themselves are divided into checked and unchecked lists. So these checked exceptions are verified at compile time, whereas unchecked ones occur at the runtime. This structure gives developers the flexibility to handle predictable errors effectively while allowing the program to fail fast for unexpected ones. So to make it easier, think of a daily life example, like if you forget your keys, it's a recoverable situation, similarly to an exception. But if your house catches fire, that's not recoverable. So just like a system error in Java, this analogy helps us remember that exceptions can be handled, but errors usually cannot. So there are two major types of exceptions, like checked exceptions. These are caught or declared during the compilation. Examples include IO exception, SQL exception, and file not found exception. They represent external factors like missing files or failed network connections, issues that are outside the program's direct control. Then we have the unchecked exceptions, also called as the runtime exceptions. They occur during, due to the logical and coding errors, like null pointer exception, arithmetic exception, or array indexed outbound exceptions. These aren't checked at compile time, but can cause your program to crash if not properly handled. So there are few common built-in exceptions like you'll encounter in Java. Uh, so this is the one that I was talking about, the example, and then we came across what is checked and unchecked exceptions. So in the built-in exceptions like null pointer exceptions, it happens when you try to use an object reference. That's null IO exception occurs during the file or the input-output operations. And the number format exception, it occurs when a string cannot be converted into a number. So understanding these exceptions helps developers anticipate failure points and build more reliable programs. Um, so as we said about the unchecked one and the common built exception types. Then the best practices in exception handling are to handle exceptions efficiently, follow a few best practices such as catch exceptions specifically rather than using a generic exception. Second, always clean up the resources. For example, close files or database connections in a finally block or use a try with resources. Third, log exceptions meaningfully, include context but avoid the exposing sensitive information. And finally, fail fast, validate the inputs and throw exceptions immediately when something goes wrong. So the AI and custom exception design, with AI assisted developments, like writing an exception, it becomes even smarter. And AI can help generate meaningful exception names, detailed contextual messages, or even assist in exception. With AI assisted development, writing exception code becomes even smarter. AI helps generate meaningful exception names, detailed contextual messages, and even assist in exceptional chaining. So preserving the original error context for better debugging, it can also automatically generate documentation describing when exceptions occurs and how to fix them, saving the developers hour of manual effort. So the key takeaways are like exception in Java are organized under the throwable classes. They help manage errors in a structured and predictable way. Checked exceptions are handled during the compilation, while unchecked errors occur at the runtime. So errors, on the other hand, represent serve systems failures that usually can't be fixed by the program itself. So that's how it went, and so this is some of the challenges that uh, that's been given, so you can try it out. And these are the two questions that's to be worked on, and these are some of the references given for you. So the next time your Java program throws an exception, don't panic. Instead, think of it as an opportunity to make your application more stable and maintainable. Remember, effective exception handling isn't just about avoiding crashes; it's avoiding writing the resilient software that communicates clearly with both users and developers. Thanks for watching. Meet you in the next video.